Today we're working on solving right triangles. We're finding missing side lengths and angles in right triangles using trigonometric ratios and inverse trigonometric ratios. Okay, so we've talked about trigonometric ratios or trig ratios. Now we need to talk about the inverse trig ratios. So in our calculator is stored all of the ratios for all of the angles. Now, there's something called an inverse trig ratio where you can get the angle if you have the two side lengths. Okay, so let's start, and then we'll talk about this text box in here in a minute, but I just want to talk about the inverse tangent. Now we are looking for the measure of angle F. So F is going to be our reference angle, and just like in the previous section, we're going to very first label our opposite, adjacent, and hypotenuse sides. So first thing is you're going to find your 90-degree angle straight across. This is going to be your hypotenuse. It's the longest side across from the right angle. Next, you're going to find your opposite side by finding the reference angle, go straight across, and this is going to be your opposite side. The last side is the harder side to find, but it's just the leftover side. It's adjacent. Now, if I'm finding tangent of my angle F is equal to TOA. So COTOA, let's just write that out. Sine equals opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent of the angle is equal to opposite over adjacent. So if I have tangent, I'm going to take the opposite side, which is 7, over the adjacent side, which is 24. Now, if I want to find what F is, I need a way to get rid of tangent. I just want to find how many degrees is angle F. And so these are not being multiplied, they're like fused together. It's the tangent of F. So to get rid of tangent, I need to do an inverse tangent. And it looks like tangent with a little -1. I'm going to move this 7 over 24 over, and I'm going to put tangent with a -1 here. Now I'm going to put this into my calculator, and when I do, I get approximately 16.26 degrees. Now make sure when you put it in your calculator, it is in degree mode and not radian mode, or you will get the wrong answer. Okay, so if it's on your calculator or on your phone, it needs to be in degree mode, and this it'll give you a completely different answer. Now, let's say instead of the opposite and adjacent values, I use sine, which is opposite over hypotenuse. Now, sine of F is equal to opposite, 7, over hypotenuse, 25. And to get rid of a sine function, I take the inverse sine of both sides, and these just kind of cancel out, and I have to do it to both sides of the equal sign. So I'm going to have inverse sine here as well, and when I put this into my calculator, if it's in degree mode, I will get the exact same angle for F. It should be 16.26 degrees. Now I bet you can guess what's going to happen when we do this with cosine. Now with the cosine, instead of doing all of this inverse stuff, if I'm wanting an angle, I can just say, hey, I am wanting an angle. I'm using cosine. Now, if I'm finding an angle, I'm going to use the inverse. So cosine is adjacent over hypotenuse, and I want to put it inside the cosine parentheses. So cosine is adjacent over hypotenuse, so 24 over 25. And if I do the inverse cosine of 24 over 25, this is going to give me my angle. Put it in your calculator and you'll get 16.26 degrees. So as you can see, it doesn't matter if you use sine, cosine, or tangent. It will give you the angle that you're looking for. Now, sometimes we don't have all three sides. We only have two. And so we will figure out which trig function, sine, cosine, or tangent, we're going to use to get the angle. Now let's look at number 2. Here's my reference angle, and like all trig problems, we are going to label the sides opposite, adjacent, and hypotenuse. Across from the right angle, the 90-degree angle is the longest side, it's the hypotenuse. Across from the reference angle is opposite, and the last side is adjacent. Now there are no letters or numbers here, so we are not going to label that side. We have something on opposite and hypotenuse. So if I look at SOHCAHTOA, opposite and hypotenuse is sine. So I'm going to use the inverse sine of opposite, 18 over 45, and that will give us our angle. I want one thing that might help you is if we're finding the angle, we're going to use the inverse. And so we can kind of think of this as AI. So, and it doesn't mean artificial intelligence here. It's saying if we need an angle, we're going to use the inverse, and we put it inside the inverse to find the angle. Now 3, we label the sides. We find our reference angle. This is opposite. Our hypotenuse is straight across from the right angle, but there's no letters or numbers there. So we're not using the hypotenuse. We are using the adjacent side and the opposite side. This is tangent. Tangent is opposite over adjacent. So we're going to have 9 over 29. It's the tangent, so we're finding the angle, so we're going to use the inverse. Okay, and then on number 4, we're going to have our angle, label the sides, hypotenuse. Opposite is straight across from the angle. There's no numbers there, so I'm going to use my adjacent and hypotenuse, which is our cosine function right here. And so inverse cosine, inverse, if you want the angle, you're going to use the inverse. Inverse cosine of 19 over 23. Now let's go ahead and put those all into our calculator, and we will get those numbers. Now on the inverse sine of 18 over 45, we should get approximately 23.58 degrees. On number 3, when we do our inverse tangent, we should get approximately 17.24 degrees for theta. And number 4, when we do our inverse cosine, we'll get about 34.3 degrees for this here. Okay, now H is going to be an acute angle. It's less than 90 degrees is what acute means. Use a calculator to approximate the measure of angle H to the nearest hundredth of a degree. So I want to get H alone. Right now it's fused with this sine. We need to get rid of the sine by taking the inverse sine. We're finding the angle, so we needed to use the inverse sine to get the sine and inverse sine to cancel. So H is going to be equal to the inverse sine of 0.2. Now to get cosine, I just can use the inverse. I want the angle, so I use the inverse cosine of 0.2. And to get the tangent, or to get h in the third one, I'd use inverse tangent of 0.2, and that will give me h. Okay, so all three of these are different values. Now, when I put the inverse sine of 0.2 in my calculator, I will get 11.54. When I put the inverse cosine in my calculator, I'll get 78.46. And when I put the inverse tangent of 0.2 into my calculator, I'll get 11.31 degrees. So all of these should have degree symbols. And again, make sure that they are in your calculator in degree mode. Okay, number 8, 9, 10, and 11, we are solving the right triangle. When we solve the right triangle, that means we're finding all angles and all sides. So when you do your homework, it will have something like this. It will have angle C and a box, angle D and a box. It will have ED and a box. So we will need to find all three of those there. Now, if I want to find angle C, it's an angle, so I'm going to use the inverse. But before I do that, I need to label all the sides: opposite, adjacent, and hypotenuse. C is what I'm trying to find, so that is my reference angle. If I wanted to find D first, that would be my reference angle. So it doesn't matter which one you do first, either way it will work. Okay, so let's start by labeling the sides. Hypotenuse is the longest side across from the right angle. Opposite is the side across from whatever your reference angle is. There's no letters or numbers on here, so I'm going to leave it for now. But I do have my adjacent side. Now, I have adjacent and hypotenuse. That is the ka of SOHCAHTOA. So the cosine is equal to the adjacent divided by the hypotenuse. So I'm finding my angle, so I'm going to use the inverse cosine. Angle C is going to be equal to the inverse cosine of A over H, so 21 over 75. When you get that answer, it will be approximately 73.74 degrees. Now, if this angle is 73.74 degrees, we can just take the fact that all triangles add to equal 180 degrees to find our last angle. So it shouldn't be too hard. Now, every one of these trig problems for this to work, it has to have a 90-degree angle here. Since it has a 90-degree angle, there are 90 degrees left for the other two angles. So if I take 90 degrees and I minus off 73.74 degrees, that will give me angle D. And that is 16.26 degrees for angle D. Now, I also need to find ED, this length here. Now, if I know two of the sides of a right triangle, I can use Pythagorean theorem to find the third side of a right triangle. So the Pythagorean theorem says that a squared plus b squared equals c squared. Our c has to be the hypotenuse, okay? It's the longest side across from the right angle. We're going to put a 75 in for c squared. A and B can be in whatever order you want. So let's call this the B side. And so our A is 21 squared plus our B, we'll just say is B squared equals 75 squared. So in my calculator, I'm going to minus 21 squared from both sides of the equal sign. Don't subtract 21 from 75. first. You have to do the exponents first. So we have to put it into our calculator just like this. B squared equals 5184. If we take the square root of that, that will give us 72 units for B. Number 9 is just like number 8. We have two sides and no angles. So I'm just going to write down angle C and angle A. It doesn't matter which one you find first, but whatever one you're going to find first, that's going to be your reference angle. We also are going to find AC. So this is what your homework question will look like. So always when you have a trig problem, you label the sides opposite, adjacent, and hypotenuse. So I have my C angle. I have across from the 90-degree angle is your hypotenuse. Across from your angle that your reference angle is your opposite side. And the adjacent side is the last side. Now, there are no numbers on the hypotenuse. I'm not going to use that. I'm going to use opposite and adjacent. I'm trying to find an angle. So I'm going to use my inverse. The inverse, I have opposite and adjacent. TOA is tangent. Opposite and adjacent go with TOA. So I'm going to use my inverse tangent. That gives me 26.56 degrees. Now, let's say I'm trying to find A. I know what C is. It's 26.56. So all I have to do is I know that every right triangle adds up to 180 degrees. I have a 90-degree angle here, so the other two angles also add to equal 90 degrees because 90 plus 90 is 180. So if this angle is 26.56 and it adds with this one to equal 90, if I take 90 and minus 26.56, that will tell me what angle A is. They have to add up to 90 degrees. So I'm going to take 90 minus my 26.56, and that gives me 63.44 degrees. Okay, now again, I have two sides of a right triangle. I can use Pythagorean theorem to find the third side. Now, on the last question, we had 75 was the hypotenuse. I don't have the hypotenuse this time. I have two legs. So these two numbers are going to go in for my A and B. We don't want to put it in for C because the hypotenuse has to go in for C. So I'm going to say that A squared plus B squared equals C squared. The legs have to go in for A and B. It doesn't matter the order on the legs, just on the hypotenuse has to go in for C. So I'm going to have 6 squared plus 12 squared. And that equals 180. And so I want C alone. So I got to take the square root of the 180. And that gives me approximately 13.42 length. So it says round to the nearest hundredth, so I'm just going to leave it like that. Now, there's another way to, another type of solving the whole triangle. That is when they give you one angle and one side, and obviously a 90-degree angle. So I need to find, to solve this triangle, I need to find angle N. I need to find LM. And I also need to find MN. Now, angle N is really easy to find. I have one of the angles. Well, I have two of the angles. We know all triangles add up to 180. So I can take 180 minus off this 90, which gives us 90 left. and then minus off 52, and that would give us 38 degrees for angle N. Okay, next we're going to find LM. Now let's just mark this as a letter. We'll just call this an X, and this is our Y. Now I only can find one letter at a time, so I'm going to have two different spots on my grid where I'm going to find the two different letters. I'm going to have one where I find X and one where I find Y. So find your reference angle. The reference angle is the angle that has numbers in it. Across from your 90-degree angle, this is our hypotenuse. Across from our 52, our Y, is our opposite side. And the X is the last side, which is adjacent. Now, if I'm trying to find the X, I'm not going to use the Y value. I have adjacent and hypotenuse, which is the cosine is adjacent over hypotenuse. I'm going to say I'm not using the inverse because I know the angle. The cosine of 52 equals adjacent over hypotenuse. Now we cross multiply here. 1 times x is x equals cosine of 52 times 3. This, if we're rounding to the nearest hundredth, this is 1.85 length. Now I want to find the other side. I can use Pythagorean theorem. However, it gets kind of messy when you have like decimals. So what I like to do is if I'm finding the other side, I just am going to use trig again. Okay, so this time I'm going to get the y value. I have, I'm going to use my 3 because it's an actual number. I'm not going to use this x. It's a big long decimal. This is an approximation, so I don't want to use 1.85. I'm going to use the opposite and hypotenuse. So I'm going to use sine, so is equal to opposite over hypotenuse, since those are the two that I'm going to be using. So sine of 52 degrees equals opposite y over hypotenuse 3. Cross multiply, y equals 3 times the sine of 52. And you can put sine of 52 times 3 or 3 times the sine of 52. Okay, and this is going to give us approximately 2.36 units long. Okay, now 11 is really similar. We have our angle. Very first, we need to find angle y. We need to find our zy and our zx. So we'll label this one as our x. This is our y. Okay, so the first one is easy to find. These two angles add to equal 90 degrees because this one is 90. And so if I take 90 degrees and I minus 29, that will be 61 degrees. So now I use my reference angle and I label the sides. I have opposite. Across from the 90-degree angle is hypotenuse. And adjacent is our x. We're finding our x, which is zx, and our y, which is zy. That works out. I'm going to label this as x and this is y. So to find our x, we want to use the adjacent side and the opposite side. I'm not going to use the y because I can't have two variables. I need just one. So opposite and adjacent is our tangent function. So TOA, tangent of 29 degrees equals opposite 18 over adjacent, which is our x. We cross multiply. 18 equals tangent of 29 times x. To get x all alone, we divide by the tangent of 29. They're multiplying. Opposite multiply is divide. and x is approximately 32.47. So make sure you put it in the right box. Like I've had people before that'll swap these and then they'll get the whole problem wrong because they didn't put it in the right place. So now we're going to get y. Y is going to be equal, we're going to find use the hypotenuse and opposite. O and H are sine of your angle equals our opposite side, 18, over our hypotenuse, which is y. We cross multiply, so 18 equals the sine of 29 times y, divide by both sides by sine of 29. This gives us 37.13 units long. Okay, our last one is just a short word problem. A boat is pulled in by a winch on the dock 12 feet, right here, 12 feet above the deck of a boat. When the winch is fully extended 25 feet, what is the angle of elevation from the boat to the winch? So the angle of elevation, remember, is you're at the bottom looking up. So we're talking about this angle. I want to know what this angle is. Now, to remember, if you want to find the angle, you have to use the inverse. So you always start by labeling the sides. Your reference angle is the angle you're trying to find. This is our opposite, straight across from the reference angle. Your 90-degree angle is here. The longest side across from the right angle is the hypotenuse. Now, no need to label this adjacent because there's no numbers there. We're going to use opposite and hypotenuse. This is sine of the angle is equal to opposite over hypotenuse, but we're finding the angle, so we're going to use the inverse sign, and then inside the parenthesis we're going to put the fraction. And so opposite is 12 over hypotenuse is 25. And that gives us approximately 28.7 degrees for that angle.